Alright, so in this video I'm going to talk about inverse trigonometric functions, and I have a couple examples to walk us through it. So anytime I have this little like -1, or I see arc, cosine, or sine, or tangent, or any of the trigonometric functions, read this as the inverse. So I would read this as inverse sine of root 2 over 2. So what is this asking? Now remember, the inverse is the opposite of our original function. So when we switch our input and our output of sine, so if we normally have sine of some angle giving us a trigonometric ratio, then now I have inverse sine of my trigonometric ratio would be equal to some sort of angle. So if I want to rewrite this, essentially I would say sine of whatever angle would give me root 2 over 2. So I'm asking myself which angle would give me a sine value equal to root 2 over 2 on my unit circle. Now there's multiple angles that this would happen at, so remember, for inverse trigonometric functions we also have to restrict our domain. For sine, inverse sine, the domain restriction is for the first and fourth quadrants, from negative pi over 2 to positive pi over 2. So I'm looking for an angle in either of these two quadrants that would give me a sine of root 2 over 2. And if I think about that, that's going to happen right here in the middle of quadrant 1 at 45 degrees, or in radians you could write it as pi over 4. So that could be my first one. Inverse sine of root 2 over 2 would be, your answer could be either 45 degrees or pi over 4. Okay, let's take a look at this one. Arc cosine of negative root 3 over 2. So this is read as the inverse cosine of negative root 3 over 2. So I'm thinking to myself, cosine of some angle equals negative root 3 over 2. Where does that happen? Now inverse cosine is restricted to quadrants 1 and 2, from 0 to pi. So let's think about what angle would have negative root 3 over 2. It would have to be in the second quadrant where cosine's negative, and that's going to happen right here at either, you could call it 5 pi over 6 or 150 degrees. Either one of those would work for that. 5 pi over 6. Great. And last one. This one's a double. Says tangent of inverse sine of 1/2. So if you ever see something like this, a composition of functions, we're just going to take it one step at a time. We're going to start with our inside. So let's find inverse sine of 1/2 first, and then we're going to take the tangent of whatever we get. So whenever I see inverse sine of 1/2, again, I see that it's the inverse, so I can kind of think about it backwards as the sine of what angle would give me 1/2. Again, we just saw sine is restricted to these two quadrants, and sine would be 1/2 right here at 30 degrees or pi over 6 radians. So let's just use degrees. So let's say this is equal to 30 degrees. So now, remember, this is just the inside of my function. I want to find the tangent of 30 degrees. And we know that tangent is our y coordinate over our x coordinate. So at 30 degrees, I'm going to take this y, 1/2, and divide it by my x coordinate, which is root 3 over 2. And when I'm dividing fractions, I can multiply times the reciprocal, and I end up with 1 over root 3. And our last step would be to rationalize that denominator so that we don't leave a square root on the bottom. So multiply times root 3 over root 3, and we end up with root 3 over 3 as our final answer.